Okay, hi everybody. I decided to change up the video format a little bit and do a whiteboard presentation. So, well, first things first. So, you would have noticed this right away if we were in a face to face class, but I am expecting. So, I'm actually due next month, a little less than a month from now. And, maybe a lecture video isn't the best time to address it, so I'll make a news item, but it should affect you guys very little. I will have a coworker cover for me for about 5 days to a week. So you will be very well taken care of. But I figured I would just mention it because you'll probably see as I'm writing on the board here. So I wanted to talk about section 3.4, which you can see I've written is the product and quotient rules. And I just wanted to briefly go through what the rules are and do a couple examples for you. Okay, so the product rule has a very specific format. Okay, so here it's called the product rule because we have a product of usually two functions. So we have an f of x times a g of x, and we're taking the derivative with respect to x of this pair. So I always say to myself, I have a little saying, and it's the first times the derivative of the second plus the second times the derivative of the first. So that would be f of x times g prime of x plus g of x times f prime of x. I think your book, flip-flops these two terms, but since they're added together, it's the same thing. Okay, so, you probably want to memorize this, develop your own way to do that. So again, we have the first function times the derivative of the second plus the second times the derivative of the first. So that is our product rule. Okay, the quotient rule is when we have a quotient instead of a product. So suppose we have the derivative with respect to x of f of x divided by g of x. Now there's lots of different ways that people kind of recite this in their head to help memorize it. What I say is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Okay, some people use low d high minus high d low over the square of what's below. So low meaning the denominator, high meaning the numerator. And so, to write that out, it would be low, and then the derivative of the high, or the derivative of the numerator, minus high times the derivative of low, or the denominator, over the square of what's below. So low squared. Okay, so whatever helps you memorize, I literally say in my head, denominator times the derivative of the numerator minus numerator times derivative of the denominator over denominator squared. But, feel free. Whatever works for you is the best way. Okay? So those are the rules, product rule and quotient rule. So I just want to do a quick example of each one just to illustrate. So erase this. All right. So let's see. For the first one, here we have f of x is equal to e to the minus x times the square root of x. And we want to take the derivative of this. So we want to use the product rule. Notice that we have a product between e to the minus x and root x. So f prime of x is equal to the first, so e to the minus x, times the derivative of the second function, which is root x. Now, root x, I honestly find it a bit easier to change any radical into a rational exponent. So root x is equal to x to the 1/2. We can then use the power rule to take the derivative of root x. So if we use the power rule here, we'd have 1/2 x to the minus 1/2. Okay, so now we have the first function times the derivative of the second function plus the second function times the derivative of e to the negative x. Now you have a rule for that this week. The rule is that e to the kx is equal to k times e to the kx. So we'll just go off to the side here. So f of x equal to k e to the kx. F prime of x is going to be equal to k e to the kx. And next week we're going to learn something called the chain rule. And so we'll get more in depth as to, why this is true. But for now, here e to the negative x, it's like our k is -1. So the derivative of e to the negative x is going to be minus e to the minus x. And now it's just a matter of kind of cleaning things up and making it look a little nicer. So we would have, let's see, e to the negative x over 2 root x minus root x times e to the negative x. And we could factor out an e to the negative x. We could leave it like that. It's a little debatable what's more simplified. Okay, but that's a problem where we use the product rule. Okay, let's do a quotient rule. Okay, so here we have x minus 1 times 2x squared minus 1, all divided by x cubed minus 1. Now we could just automatically, if we want to take the derivative, we could just automatically start with the quotient rule. I will warn you though, it's messy. There's a lot of algebra in it. So whenever you see a problem like this, I would always check for any possible simplification. Now you're not always going to be able to simplify it, but sometimes you will. So if you notice, we have an x minus 1 term in the numerator, and then in the denominator we have a difference of cubes. So this is probably going back a little ways, but there's actually a formula for factoring a difference of cubes. So let me put the general formula over here. Okay, here's a cubed minus b cubed. That factors into a minus b times a squared plus ab plus b squared. Okay, so that means that we can factor the denominator into x minus 1 times the quantity x squared plus x plus 1. Okay, and so hopefully you've seen that before. It's just factoring a difference of cubes. There's a very similar formula for factoring the sum of cubes. Okay, but now we see that we have a common term in the numerator and denominator. X minus 1 over x minus 1 is 1. So we can simplify this to be 2x squared minus 1 over x squared plus x plus 1. And so this is still our h of x function, and our task is to find h prime, but we still have to use the quotient rule, but it's much simpler now. Okay, so be on the lookout for simplification. Okay, so h prime, well, so using the quotient rule, we have the denominator times the derivative of the numerator, which would be, whoops, computer went to sleep, there we go, which would be 4x minus the numerator times the derivative of the denominator all over the denominator squared. Okay? And I'm actually going to leave it like that. In general, you probably want to look for some simplification to see if anything will cancel. Often things will cancel in your final form, but I just wanted to illustrate kind of the method in this video. And I'm trying to keep these videos short because I know that, people probably don't want to watch an hour-long video of me writing on the whiteboard. So hopefully that kind of helps. I looked at a lot of the discussion posts, well, all of the discussion posts from week 4. People are doing a really beautiful job with the power rule, the constant multiple rule, using the definition of a derivative, all of that. Everyone's doing really great work. So keep up the good work, and I'll see you again in section 3.5 lectures.